Okay, so we're starting section 3.7, the properties of exponents. I'm doing is I've already put up some stuff we need to already know. We have learned this in previous chapters. Exponential notation, remember, is the base number multiplied times itself, whatever exponential number you're given. So 2 to the power of 3 or 2 cubed. 2 is the base number, 3 is the exponent, and you multiply 2 times itself 3 times. That's what the exponent means. You would never multiply a base number times its exponent. That's just basic multiplication. We wouldn't need to have that in exponential form. The second thing is the zero exponent property, which you've learned and should have learned in previous years. I don't know that we've necessarily gone over this yet in this class, but we might have. But it is that any number raised to the power of 0 equals 1, as long as that number is not 0, because if the base number is 0, 0 times anything is 0, so it would be 0. But when you have a number raised to the power of 0, that is always equals 1. I believe we did scientific notation in a previous chapter, and that's where we learned about the 0 exponent. But let's go ahead and move on. So in this lesson, this you don't have, you should know, or what you're going to learn here is how to, don't necessarily have to write this down, but how to simplify an expression using the properties of exponents. All right. So numbers expressed in exponential form can be multiplied and divided easily if they have like bases. So you just keep the base the same and you just learn based on the properties of exponents how the exponents interact with each other. And this works with numbers as well as variables. We use it with variables because with a variable, you don't know what that number is. So you can't multiply it times itself. So you manipulate the exponents. But the examples we're going to start with are with numbers, so you can see how the process works. So, for example, to multiply, you must add the exponent. So let's look at an example of this. So let me figure out. So I'm just going to put a note here that when multiplying base numbers, like base numbers, you add the exponents. Let me show you why this works. So if we have 3 to the power of 3 times 3 to the power of 4. Now, we could separate all of these out and do the multiplication. If you expand the powers, 3 to the power of 3 is what? It's 3 times 3 times 3, right? And we're multiplying that times 3 times itself 4 times. 3 times 3 times 3 times 3. All right. So this is all multiplication, so we can ungroup these. So you can expand the powers. That's what this is. Now, you will not be doing this every time. I'm just explaining to you why it works. Now let's ungroup the factors. This is 3 times 3 times 3 times 3 times 3 times 3, 7 times. 1, 2, 3, 4, 5, 6, 7. Yep. So now we've ungrouped the factors, the base numbers. Now, because by definition, an exponent is how many times a number is multiplied times itself, we can tell that each of these numbers is 3. So we can rewrite this as 3, and then how many times are we multiplying 3 times itself? Yep, 1, 2, 3, 4, 5, 6, 7. So our exponent is 7. So we rewrite the product in exponential form. Instead of doing all that, we can just add the exponents. So let's look at this again. Draw an arrow here. So 3 to the power of 3 times 3 to the power of 4. So let me keep my base number 3 and just add my exponents, 3 plus 4. Well, what's 3 plus 4? 7. So that gives me 3 to the power of 7. So that, so much easier, right? Than all those steps that we just did before. Expanding it all out, adding them all together, and then putting it back. So that will work every time. But the rule is you must check the base number. It has to be the same. If it's not, this does not work. This only works because we're multiplying 3 cubed times 3 to the power of 4. That base number is the same. All right, so we call this the product of powers property. Now, this example is of what I just did is an example of the product of powers. But it's stating that for any number x and integers a and b, that x to the power of a times x to the power of b will equal x a plus b. So that's our first property of exponents. All right, so in example 1, they do what we just did. They want us to write -3 squared times -3 to the cubed as a simplified power, and they want us to do it by expansion and by the product of powers property. I'm just going to do the product of powers property because I feel like you two probably understand the whole expansion thing based on my first example.
We don't have to share. We don't have to solve them.
Just simplify. Exactly. So let's look at an example of this. So if I want you to write, I'm on page 128. So write -3 cubed or squared, excuse me, times -3 cubed as a simplified power. All right, now here's the really important thing. If a number is negative, you must keep the negative in parentheses because it's important because a negative times a negative is positive. And so you need to make sure your answer may not always be negative if you simplified it to a whole number. So it has to stay in parentheses. So in this case, what's our base number? -3. So I have a -3. And then what are my two exponents? I have 2. And I add that to 3. So when I simplify this, my base number never changes. It's still -3 inside parentheses. But what is my new exponent? 5. And we're done. Okay, so the next property we want to look at, we need to ask the question, what happens when you raise an exponential expression to a power? So if you have an exponent raised to an exponent. So let's look at this. So if I have, change colors here, just keep myself on track. Let's say that I have 2 to the power of 3 raised to the power of 2. So let's expand it first so we can see how it works. 2 cubed squared means I am multiplying 2 cubed times itself how many times? Twice. Right. So now I have 2 cubed times 2 cubed. So what's the rule that I just learned about exponents when I multiply them? What do I do to the exponents? You add them. So this simplifies to 2, 3 plus 3, which is 2 to the power of 6. So our property is the power of a power property. I'm gonna move on up here. So power of a power property states that for any number x in integers a and b, x raised to the power of a and then exponentially raised to the power of b is equal to x a times b. So let's go back to our example above. Did you leave any room between the two? Actually, you know what? I'll keep it below. So after you write this property, let's look at the example above, right? We had 2 cubed raised to the power of 2. And that was 2 cubed times 2 cubed, which meant we added 3 plus 3, which gave us 6. So let's look at that again using the power of a power property. So if we have 2 cubed raised to the power of 2, and we know based on the power of a power property, that is hard to say multiple times, that instead of adding power of a power property, yep, I feel like Peter Piper picked. I'm doing a tongue twister. So picked a pill, picked peppers. Yep. Okay, so in this case, it's telling us that if you have, this is 3 raised to the power of 2, what do we do with those two exponents? In this case, we multiply them. So 2 to the power of 3 times 2, and what's 3 times 2? 6. Which is the answer that we got up here. So in this case, you don't have to expand it based on that top exponent. Instead, you just multiply. Okay. So let's look at another example. All right. Again, I'm going to use the power of a power property, which is the second part of this. So our example asks us, is that your pencil again? All right. Oh, not mine. You just sit there and do the thing. Write x to the power of x squared raised to the power of 4 as a simplified power. All right. So we know based on our rule that we can write x squared raised to the power of 4 is equal to x what? What do we do with those two exponents? We multiply them. So 2 times 4, which equals 8. Yep. And that's it. So if you see a power raised to a power, you just multiply those numbers together. And that works because if you did it in expanded form, it's x squared times itself 4 times. So it's 2 plus 2 plus 2, which surprisingly enough also equals 8. That's good. Yeah, writing notes is good for that. All right. So we have those two properties. They have them together in one box right there on page 129. Your review guide will also have a worksheet where you can fill these out with the property and an example. So it kind of puts it all in one neat place for you as well. So let's go ahead and work on skill check A, and then I'll have it set up so that you can check your answers. Let me see if I can pause it without actually quitting. Okay, I think I kept it as one video. Okay, so 5 cubed times 5 to the power of 4. Do we have the same base?
Yes.
Yes, so what do we do with those exponents?
Add them.
We add them, 3 plus 4. So that gives us 5. Okay, it's gonna be crazy.
5, 7.
5, how do we say that? 5 to the power of 7. All right, what about number 2? So what are we doing with our exponents?
Adding.
Are we multiplying?
Times.
We're timesing them. So this is 3 times 3,
9.
which is 2 to the power of 9. Perfect. Okay, what about y? What are we doing? We're adding them. What's the exponent of that second y?
2.
That's the first y. What's the exponent of that second one? With no, the 1. So what's 2 plus 1?
3.
There you go. Y to the power of 3. So that's a good example to have. Remember, when you're adding, then it's going to increase by 1. So that 1 becomes important because you're adding it. All right, for number 4, what are we doing with these exponents? Multiplying them, yes. So this is 2 times 5, which is x to the power of 10. Excellent. What about 5? We have b. What are we doing with those exponents?
Multiplying.
We're multiplying once again, yes. So this is b, and 6 times 3. Yeah, this is why. This is so much easier, right? If you had to expand this out 5 times or 3 times, then add them together. That's why we have multiplication. So b to the power of 18. All right, now what about with 6? What are we doing with these exponents? What are my exponents?
3 and 2.
And?
1.
And 1. Don't forget that 1. So these exponents are 1. Are we multiplying or adding? Adding. So this is 1 plus 3
6.
plus 2, which equals 10 to the power of 6. Awesome. Okay. Hang in there. I want to introduce the quotient property and get through skill check B, and then we'll finish this up tomorrow. That should give us time to work on the homework in class tomorrow, so maybe you won't have too much left tomorrow night. All right, so powers with like bases can also be divided. So far, we've worked with multiplying and raising to a power. We can also divide. So for example, if I have, let's see, we're gonna dividing like bases with exponents. Yeah, I can't spell. P-O-N-E-N-T-S. So the example we start off with is we have 3 to the power of 5 over 3 to the power of 3. So again, if we expand this, okay, it's really weird the way they wrote it. We'll just do it this way. All right, 3 times 3, 5 times. Over 3 times 3 times 3. All right, so the 3 times 3 is what? Or 3 divided by 3 is what?
1.
1. So these actually cancel each other out and they become 1. So what else cancels each other out? And so what are we left with? 3 times 3, which we write how? With an exponent, exponential notation. Base number,
Yeah. Base
3.
number, and then
How many times are we multiplying it times itself?
2.
2 times. All right, this is why subtracting works. So we have 3 squared as our answer. Now, if we use the quotient of powers property, this states that for any number, as long as any number x, as long as it does not equal 0, and integers, so this means positive and negative whole numbers, a and b, x, let me put this somewhere it's easier to see, x to the power of a divided by x to the power of b is equal to x a minus b. So when we multiply, we add. So when we divide, that means we subtract our numerator's exponent minus the denominator's exponent. So let's look at the example from before. So if we have 3 to the power of 5 divided by 3 to the power of 3, if that equals the base number 3 raised to the power of 5 minus 3, what's 5 minus 3? 2, right? Which matches our guy up here. So that's why, the expanded form, we don't have to use the expanded form. We can just use the quotient of powers property. And that's going to give us the method for simplifying exponential expressions where you have a base number divided. All right, so let's look at another example. Just a smidge. So I want you to write 4 to the power of 6 divided by 4 to the power of 3 as a simplified power. All right, so what's my base number? 4. And what are my exponents?
6 and 3.
So which one minus which one?
3. 6 minus 3.
6 minus 3, yes. So that gives me 4 to the power of what? So we're looking for
3.
4 to the power of 3. So 4 cubed. Yes. All right. Whatever helps, right? All right, so let's get through skill check B, and then tomorrow we will apply the properties. Okay, so hopefully you've gone through skill check B. Let's go ahead and check answers. So 2 to the power of 7 divided by 2 to the power of 5 means that we do what? Base number is 2, and then the exponent is 7 minus 5. So our answer is 2 squared. Should probably do that in different color. Sorry, OCD is kicking in. I'm gonna have to change this one if I'm gonna do all the others. There we go. 7 minus 5. Okay. So for number 2, our base is a variable, m. It doesn't matter. Property still works the same. Actually, you know what? Let you catch up. So what's the exponent of my numerator?
1.
That's the denominator.
M.
M is the base number.
6.
And then we have 6. What? 6 minus what?
1.
1. Very good. So you have an understood exponent of 1, and 6 minus 1 is? So m to the power of 5 is our answer. Okay, and then the last one, our base number, 11. Yep, 4 minus 2, which gives us 11 squared. All right, so we're gonna leave it at that for today. It's Wednesday, so no homework. We will pick up with example 4 tomorrow, as well as get a head start on some of the practice homework. All right, I'll see you tomorrow.